Wah, 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 wah. Kind of hard to understand with that mask on, isn't it? All right, we're going to be dealing with completing the square today. Before we do, let's have a little fun. Foil this. Who's got it? Come on, hand up, quick. Yes, sir. How many people went through every step of doing it? Anybody do it quicker? Let's try this one, please. Seriously, 5 seconds. 3, 2, 1. Who's got it? X squared plus 7x plus 10. Anybody beat me? There's a trick. There's a way to do this faster. Let's try another one. Oops. Go. X squared minus 2x minus 15. Well, you're the teacher. You know how to do it. How'd I do that so fast? Look at it. Anybody come up with something? Think maybe could help them be faster? Ethan?
Whenever you're trying to get the, like, you're just multiplying the two x's and the two numbers, and then, like, you're just adding them together and putting an x on the end.
Absolutely. We're multiplying them to get the constant and add them to get the middle term. Look at this. 3 and 5 is 15. Negative 5 and 3 is 2. Right? Add them and multiply them. Add them and multiply them. Add them and multiply them. You ready? Try this one. Go. X squared. Somebody quick. Add them. What do you get? 7 minus 4. It's 3x, right? And negative 28. Yes? Go. Raise your hand when you got it done. Go ahead. Yeah. Yeah. Let's try another one. Fast. Ethan? Excellent. Try another one. Woohoo! Next one. Go. Speak up. Yes. Rocking and rolling. Cool. Now let me show you something specific about these last three. See this one, and this one? Those three are what we call perfect square trinomials. Yes? Absolutely. Perfect square trinomials. How did you get those so fast? Well, add and multiply. Yeah? So you should be able to identify those somewhat quickly. Okay? For example, this one. Is that a perfect square trinomial? Absolutely. See that perfect square right there? What's the square root of 25? 5. What's 5 plus 5? 10. Hey, that's a perfect square trinomial. So I should be able to factor that to be x plus 5 quantity squared, or x plus 5 times x plus 5. Yes? How about the next one? Is that a perfect square trinomial? So what is it factored? X plus 6 quantity squared. Oh, cool. Boy, that's actually pretty easy, isn't it? Let's try another one. Antonio? Yes. Rocking. Let's try this one. Yeah. All right. Hey, that's pretty easy, isn't it? We talked about this over the last couple of days saying, hey, this is a perfect square trinomial, and you're going to want to be able to identify these. And once you can identify them and see them, man, it becomes really easy to factor, doesn't it? Matter of fact, we said there was another one that was that way too, and it's this one. This one's called the difference of squares. DOS, all the students got to get it. You better recognize when I spit it. You know what I'm saying? This one is x plus 3, x minus 3. Remember? We've talked about these, yes? Difference of squares. It looks like it's very similar to the perfect square trinomial, but instead of being the same sign in both, it ends up being opposite signs. Okay? Two perfect squares separated by a minus sign. Difference of squares. So what would this one be? Come on. Give it to me. Yep. Yeah. Next one. Yeah. Rocking. Someone else. Someone else. Tristan? Yes. Good. Mr. Beckley? Stephanie? Yeah. X plus 9, x minus 9. All you got to do is take the square root. Yeah? Cool. Now, I wanted to show you that. Just kind of do some simple multiplying, foiling, and factoring before we get into this completing the square deal. Okay? Because completing the square is a process where I want to create a perfect square trinomial. Is this one a perfect square trinomial? Obviously not. That 7 is not a perfect square, is it? Okay, so I'm going to do something here with this one. I'm going to take that 7. I'm just going to move it over here out of my way for a little bit. What would need to be right here at the end for this thing to be a perfect square trinomial? Yes, sir. 64, close but no cigar. 56, All right, let me go back here. You know, and on these, let's go to, I don't know, this one right here. How did we get 6? Yes, sir. 6 times 6 is 36. Good. So you took the square root of 36, and that's fine. Is there another way that I can get 6? Yes, sir. Okay, take away 30. That works in this particular case. How about we do this? Instead of looking at the last number, look at this number. Yes, sir. 12 divided by 2. 12 divided by 2. Let's look at this one. Yeah, you could take the square root of 25 and see that it's 5. Or what? 10 divided by 2. So not only could I take the square root of the last one, I can take half of the middle term. Agreed? Okay, let me go back over here. I don't know what the constant is, do I, right now? But I do know what my middle term is, yes? My middle term is 8. What is half of 8? 4. Am I going to add 4? No, I'm going to square that. So it would be 16. So if there was a plus 16 right here, this would be a perfect square trinomial, wouldn't it? Wouldn't it? Okay, well, we're going to use that knowledge and that idea to do what we call completing the square. Okay, I'm going to create a perfect square trinomial in here, but I can't just randomly add 16 to something. You just can't do that. Okay, I could randomly add nothing to it. Yes? If Ethan, I'm going to give you $20. Here, Ethan, $20. And you know what? I'm going to take it back. What did I just give Ethan? Nothing. I didn't give him anything. Can I do that? Can I give him nothing? Yeah, Ethan doesn't like it, but I can do it, yes? Can I give 16? Can I give nothing to an equation? Sure. So if I give it 16, what do I have to do? I've got to take that 16 away. So now I really gave it nothing, didn't I? I can do that, can't I? I can add 0 to something, can't I? Sure. And look, by doing that, by giving it 16 and taking that 16 away, I really gave it nothing. However, right here, I have a perfect square trinomial. And we've already shown that we can factor those super quick, can't we? That would be x plus 4 quantity squared. Cool? All right, now these numbers over here, could I add those numbers together? Sure, they're both constants. Negative 16 plus 7 is negative 9. Hey, look at this right here. What form is that in? Vertex form. That's vertex form. What's my vertex? Negative 4, negative 9. Wasn't that easy? That was really easy to manipulate that equation from standard form into vertex form by completing the square. Let's try another one. All right, let me take you through the process. Okay, first things first. I'm going to take this 8, and I'm just going to move it over here out of my way. Okay, and in the space, I'm going to add and subtract something so I create a perfect square trinomial. Well, what am I going to add and subtract? I'm going to take this middle number, which in this case is a 6. I'm going to divide it by 2. 6 divided by 2 is, and then I have to square it. 3 squared is. So I'm going to add 9, and I'm going to subtract 9. So I really did nothing. I'm really good at doing nothing. Get it? Really good. All right, anyhow. Here is a perfect square trinomial now, which I can factor to be x minus 3 quantity squared. How do I know it's minus? Because of that sign right there. And then I just put those two constants at the end together. Negative 9 plus 8 is negative 1. There it's in vertex form. What's my vertex? 3, negative 1. Think you can handle it? Let's try the next one. I'm going to give you a few seconds to get it started. First thing I'm going to do is I'm going to move this 15 over just a little bit. Give myself a little room to work. And I'm going to add nothing to it. But in this case, the nothing's going to look like a plus 36 minus 36. How did I know it was 36? 12 divided by 2 is 6. 6 squared is 36. Now this is a perfect square trinomial. Factor it. X plus 6. Hey, that 12 divided by 2 is 6. And then 6 squared is 36, right? I'm doing that kind of in my head. But look, this number is what I have down here, isn't it? That's pretty cool, isn't it? Makes it a lot easier for me, doesn't it? Sure. And then negative 36 plus 15, negative 21. So my vertex is what? Negative 6, negative 21. How many people got it? Ready to try one totally on your own? I'm going to give you 30 seconds. Go. And let's go to work. Move the 7 over. Give myself a little space. 10 divided by 2 is 5. 5 squared is 25. So plus 25 minus 25. X plus 5 quantity squared minus 18. Vertex, negative 5, negative 18. How many people got it? Rocking and rolling. Can you handle it? Okay. On your Google Classroom is a worksheet, but I only want you to do numbers 1 through 10. 1 through 10. Okay? Good luck.